The thought of buried wealth plucks a sentiment in those of us who are treasure hunters, addicted to the adrenaline of possibility. We can't ignore the pull of gold, and you begin looking with a pan that you'd ordered off Amazon. It has custom-designed ridges and great reviews. Huge excitement heralds your first outing. Your wife waves you off at the door, but you come home in a cloud of disappointment. You're reminded that if gold was that easy to find, the riverbanks would be crowded with others like yourself. Now think about this for a moment. All the gold ever mined in human history could fit inside a 20-meter square cube. Every hurricane-blown Spanish galleon that floundered on a Caribbean reef, everything in Fort Knox, every golden bangle in India combined could be melted into that single gleaming box. It's mind-blowing. So how do we find this precious metal and add to the sum total? Well, gold doesn't just appear. It's a complex process of erosion, transportation, and concentration. Initially, surface gold is spewed from the Earth's interior within the mid-oceanic trenches. Molten magma wells up with trace gold to replenish the continental crust. Initially, gold atoms are thought to have formed in a process termed as rapid neutron capture, which takes place in the unimaginable conditions of a neutron star collision. Deep in the oceanic trench, from whence the continents are born, cooled rock then moves off conveyor belt-like with its trace gold in either direction. Gold is a rare element, found at about 4 parts per billion in those forming crustal rocks. The key to the discovery of a profitable deposit lies in how gold is brought together. There's only time and natural processes to consider. But in those natural processes lies a secret that gold prospectors the world over should know. The gold can be in plain sight, but remain unseen. Many a rich deposit has been overlooked for this reason. Relative weight is the first mechanism of concentration. Gold is incredibly heavy. When it's eroded out of rock, it gets moved by wind and water, accumulating where natural obstacles stop its flow. Imagine a river with an inner bend or a deep fissure. These are the places where gold tends to settle. Gold's density is 20 times that of water. So when the water slows down, gold sinks and concentrates with other heavy materials. Unlike lighter quartz and sand, they just float away. Considering how little success gold panners have had in Ontario, you'd think that there's no gold to be had here. But it's not the case. In 2022, 3.9 million troy ounces was extracted from the province's rock. It's a quantity valued at 5.4 billion. There's tons of gold in Ontario, literally. So again you ask, why is my pan empty? Around 14,000 years ago, the last ice age ended, and glaciers scraped back across where they'd already come from. Gold that had been concentrated by the rivers in the pre-glacial landscape had been carried southwards by the ice. It was left in drumlins, moraines, and eskers, up as far as the banks of the Mississippi River. Redispersing the gold ruined the concentrating effect of millions of years of flowing water. What resulted from that unintended redisposition was glacial features that are gold-bearing but uneconomical for mining. The second mechanism of concentration involves the movement of superheated waters, also known as hydrothermal fluids. The water is heated by a nearby magma body known as a batholith, or pluton in geological terms. This heated water that carries the gold is rich in carbonates, often from limestone or dolostone. Fissures formed near the surface due to the rising batholiths. They act as conduits where these hydrothermal fluids deposit minerals that precipitate with decreasing pressure and temperature. The western edge of the Canadian Shield, where the majority of Canada's gold is found, is riven with fissures and fault lines. They call them breaks, and the offshoots are called splay faults. Though it is the gold that is most ardently sought, and there are many other minerals that have been concentrated near the surface in such fissures.
Oh man, look at this. Unreal.
Just south of El Dorado is Madoc, and there it is possible to see deposits that have filled a huge fracture that runs for several miles, passing under Moyer Lake. and the town. It's thought to be a tectonic feature that hosts the area's mines, part of the Ottawa-Bonnechere Graben. It's the same concept as the Northern Breaks. It's just that the element in Madoc is fluorite, and in Timmins it's gold. So the concentration process is quite common. It's just that the terrain through which the water has passed can hold a wide range of minerals, and in Madoc's case it was fluorite that was relocated by the hydrothermal fluids, not gold. In 1866, a man named Marcus Powell was digging in a copper vein on the Richardson farm, just north of Madoc. He never expected the ground to collapse beneath him, but it was his lucky day. A hidden cavern was revealed that was lined with sheets of gold. A nugget the size of a butternut sat there in front of him. News soon got out, and it set off a gold rush. Yet despite the excitement, the prostitutes, the expectant miners, and the scammers, not another ounce of gold was found. Caribou Cameron led a mob that threatened to storm the mine property to see if the gold really existed. The Mounties settled the uprising with a compromise. Caribou went in to confirm the existence of the gold. The mob was satisfied. But where was the rest of the gold? How could it accumulate exactly there in that hole and nowhere else?
Three.
Okay. Oh, look at this. Yeah.
Here's his blast hole, his blast mark.
Okay.
Right? So
Okay.
as he started digging this out, the ground gave way,
Uh-huh.
and that's the cave.
That's it down there. Amazing.
That's it
That is so cool.
there. Nice little, you see how it goes right
Yeah.
over to the top?
Uh-huh.
Okay, I had the University of Windsor in here, and
Uh-huh.
this has always amazed me because everything else is on a horizontal except for that. So I took it in.
So the rock has radioactives, bismuth, yttrium, the rare earth yttrium, everything. 37, I think it is, 37 different types of mineral in the actual seam or fissure. So this comes from way deep down. It came up from the plutons that underlie this area, probably made fractures. So this is probably a fracture that it filled in. You can see the quartz fissures all along here, and this is a tunnel there down at the bottom that joins on to another one of these shafts. And as I say, it's quite the distance up.
Opposite side you should see a bug of all little quartz crystals.
Climbing the TV tower back out of the pit.
Well, it had to get there up a fissure and be concentrated by some kind of natural process. Well, therein lies the secret. Sometimes gold isn't just sitting there easy to grab. It can be trapped in other minerals like arsenopyrites. In cases like that, the gold is said to be refractory, locked inside a mineral's crystal structure. You can't see it, but it's there. The gold is more challenging to extract, but when the mineral breaks down, it can release gold in the process. So it's possible that gold, discovered in that cavern, could have been hidden in arsenopyrites, and in a natural decomposition process, it was released into Marcus's hidden cavern. It would appear that iron and copper pyrites are a regular feature in other nearby gold mines, along with arsenopyrite. There are several failed gold mines within a few kilometers. All were extracting free milling gold. Seeing the arsenopyrite crystals piled atop several of the El Dorado property's shafts, I'm wondering what's wrapped up in the hidden world of their atomic structure, and how far beneath the initial hole the arsenopyrites extend. Arsenic plays a crucial role in concentrating gold. It's like a sponge that draws up all other gold around it. When gold combines with arsenic, it forms a stable bond, bringing the gold atoms closer together, sometimes by 1,000,000 times more than they would naturally be. This process will make gold invisible to the naked eye, but it's still there. As the arsenopyrite weathers and breaks down, gold may be released from its imprisonment in a process called brittle deformation. A recent geologist survey just north of the El Dorado property indicates a treasure trove of over 145,000 ounces of gold still buried beneath the surface. But much of this gold is refractory, tied up with arsenic, making it harder to extract without specialized methods. Yet the potential for wealth is huge, overlooked before knowledge caught up with observation. The golden El Dorado isn't just a historical footnote. John Richardson, who owned the property where Marcus Powell made his discovery, passed down a simple gold ring to each of his children about 160 years ago. Today, the Richardson family still gathers in El Dorado, with 6 descendants each wearing those same rings minted from Marcus's initial discovery, symbolic of a story that's still to be continued. I believe that the plot is written in the lattice of arsenopyrite and a fissure that extends down beneath the original mine.